Dr. Rastgu, have you heard of Bob Lazar?
Yes. Oh, we are
Yes.
going that way. Okay.
Yes. Let me ask why. I mean, let me explain why. Because we were talking earlier about the possibility of, I think Parker was mentioning, like, these instruments, these engineering instruments that could far exceed what we know today. So my question is, well, to those people that don't know that don't know Bob Lazar, well, he's kind of like he's a physicist that works in an area kind of off. What's it called, Parker? I think you
It's
know it, right?
Area 51. Okay,
No,
it's
no,
a
but
laboratory.
it's called S something, right?
S4
S4,
at
something
Los
like that. Yeah, and
Alamos.
he was on a Joe Rogan podcast where he was talking about a lot of his experiences with anti-gravitational machines. Now, I heard that and I just flipped. I'm like, no way that's possible. So I guess my question here is, well, first off, do you believe he's telling the truth? And second off, if you do, if it is true, what do you think that would have an impact on our like understanding of quantum theory?
And also, sorry,
Yeah, go ahead.
just to add another question, in with all of your years of study, is there any hint, indication towards an anti-gravity particle or
Something like that,
thing?
yeah.
Right, yeah.
Okay, so that's the first question. I don't know if he's telling the truth or absolutely. I don't know him. I don't know anything about.
Mhm.
So that's I cannot answer the first part. The second part is about something we call anti-gravity. So that's based on the interpretation. So um, for example, if you look at the paper that's called the warp drive by Miguel Alcubierre from actually he's also in Mexico. That was I think the first paper published in putting this warp drive into physical context. So it basically gives you formulation of that. Of course, there are some serious issues with that. You need some exotic mass or exotic matter for that. But I mean, people at least at NASA took it seriously to kind of study that, work on that. Anyway, so because that's a scientific paper, I can talk about that. That paper tells you that given that you have this sort of weird matter, let's say we have it, you can create at the back of your spaceship and in front of it, basically put your spaceship inside a bubble. A bubble is space-time in which inside is different from outside. We have something gravity is called metric. And the metric basically is the gravitational field, if you want. This metric, as I mentioned, this is very, very interesting, that gravitational field, sorry, I just digressed a little bit. So the gravitational field, as I mentioned, is the space-time and its causality and all those things, creates all of that. So the metric is all of these things at the same time. The metric tells you what is the distance between objects, what is the time distance between the space distance or the space-time distance, and all causality and all of those things. That's why it's called metric, right? It kind of measures the distance, if you want. So this metric or gravitational field, you can modify just around the spaceship such that outside you have just usual, if you want, flat space-time, and inside you have some sort of curved space-time. And the metric field or gravitational field behind the satellite or that object is kind of, if you want, positive or yeah, so it's pushing the spacecraft, so creates a positive what is the word, hill, if you want, and in
Okay.
front of the
I think the analogy is that if you have like a marble on like your bed or something, and then you press down in front of the marble, it'll start accelerating, and then
yeah, so you have to bring the gravitational field up at the back of
yeah.
the spaceship and create a valley in front of it so that it constantly moves forward. But the beauty of this is that what is moving is actually not the spaceship itself. The spaceship inside its local space-time, so that bubble is just sitting still doing nothing, and that bubble itself is moving around. That bubble of space-time moving inside the exterior space-time. And this has really nice at least two really good advantages. One of them is that there's no problem with acceleration. So because one of the problem with space astronauts and all of that is that our body cannot take that much acceleration, maybe 10 Gs, or I'm not sure how much, but that's some sort of like that. So even if you have the technology to reach this close to the speed of light, you can do it. You have to do it very slowly if using traditional technology. But in that case, you are just sitting still there and you are not moving. The space-time is moving, so you don't feel acceleration. So you can immediately go from 0 to close to the speed of light. The second thing is that because the space-time itself can expand or contract or move around if you want with any speed it wants. So it's not bound by the speed of light. So you can just move around even faster than the speed of light. And from the viewpoint of somebody that is close to this spaceship, you can think of that you can think of that as either gravity or anti-gravity, because it's just moving weirdly, right? So that is a problem of interpretation. Maybe that's true, but it's not really anti-gravity. It's just gravitational field itself, but you can manipulate it in weird ways.
So technically, the warp drive is not really breaking special relativity then, because just hearing the word warp drive, you're like, oh, superluminal, but that right there would break all the laws that we've been brought up with, right? So so would it work in such a way where, because you were describing like we're creating more space, and technically like that wouldn't break special relativity. Like how would a warp drive exist? Basically my question, I guess I can form, is how would the warp drive exist without breaking special relativity?
So it is basically based on general relativity, which is it's a more complete theory than special relativity. So in general relativity, you have all those things of the speed of light and blah, blah, and then you also have these additional things. You're creating this warp drive actually using general relativity. So basically the theory is relativistic completely. The problem, or actually the advantage is that what is moving around is not really the satellite or the spaceship with respect to its immediate spacetime. It's the bubble spacetime with respect to the outside spacetime. And we know that is absolutely possible. We see that the high redshift in cosmology, things are moving apparently faster than the speed of light, but that doesn't mean that they're really moving. The matter is moving faster than the speed of light. It's just a space-time itself, and then drags the galaxies and all those things with itself. So it's absolutely possible not to violate special relativity or general relativity because you are not moving material objects faster than the speed of light.
Oh, wow.
So all we have to do is figure out how to do that.
Yeah, so if you want to basically curve a space-time around the spaceship in a certain way, there's a issue in that. I will mention that, but basically you have to do that, and then that's it. You can go on. So the issue is that for that, at the moment, the theories that we have, the papers, you have to have some sort of, if you want, exotic matter with negative energy density or negative mass, if you want. So we don't have that. Even if you have that, you may need a lot of matter to curve a spacetime in that way. So the spacetime is like a fluid, but a very stiff fluid. In order to curve it, you know that you have to put a really, really large mass there, like a sun there or Earth, and so it's not easy to put in a small amount of space a large mass, because it creates a black hole. Then you have to deal with that, and so yeah.
Imagine accidentally you're like, hey, let's do this. Boom, create a black hole. Entire experiment just done.
I think entire Earth is done.
That'd be pretty funny.